And you could do that, I mean, so you could do exactly that, or when you're going over that multiple choice quiz, asking the kids, what's wrong with the other 3 answers, or 2 answers, or 5 answers, or however many you have on there. Because that error analysis can be really powerful, whether it's their own error, or whether it's, you know, somebody else's error, but, you know, using that stuck point or that mistake as a jumping off spot. Because that'll sometimes either reveal misconceptions or allow you to address a misconception, you know, right there in the classroom. I mean, if you have one student that's doing something a little interesting, you might choose to then have a conversation off to the side. But if you've got half your class making the same kind of mistake, or they're getting stuck in the same spot, thinking strategically about how do you use that as a place for learning. And again, in some classrooms you can just have the kids say, you know, this is what I did, and you can think about it. As you're building that culture, if the kids aren't quite to that point, then write it down on a piece of paper and slide it underneath there, then it's in your handwriting. Okay. All right. So one thing I know I have been remiss about here is I have not stopped very often to give you a chance to reflect. So I want to give you a chance. Pull out those important moments. Jot down something that you're thinking about right now that you don't want to forget, that you want to keep track of as we go forward. I'll give you a second to do that. Or actually a minute or so to do that. Chance to do some math together. We've had the chance to kind of think about how we might bring alive the mathematical habits of mind and habits of interaction in our classrooms, which are all really important pieces. But I want us to think about one more connection here before we start to wrap up. We've got a little over an hour left. I'll be cognizant of the time. One powerful way to measure the Common Core State Standards for mathematical practice as student outcomes is to think about discourse. So as you listen to your students talk in the classroom and you look at what they're writing down, being able to determine how they're engaging in the mathematical habits of mind interaction is one thing that you can do for them. So thinking about why student mathematical discourse. Increase in the level of discourse in groups produces greater student learning. Explain to other students is positively related to achievement outcomes even when controlling for prior achievement. However, just getting students to talk was not enough. What they talked about mattered. So we're going to have a chance to think about discourse in just a moment, and we're going to get a chance to take a quick peek at a short video of a classroom where students are being asked to do exactly this. And we're going to get a chance to think about how do we know what they're understanding by listening to what they're talking about and looking at what they're writing down. Okay? So we're really after, once again, we're after this make sense, justify, generalize. So that last little bit there, getting students to talk was not enough. So if we just have them talking, that's good, but it's not enough. We want to think really hard, what are they talking about? What are we giving them to talk about that's going to help them make sense, justify, or generalize about the mathematics? Are they looking at some mathematical representations and making some connections? Are they looking at some patterns and then thinking about what might always be true? Are they doing some error analysis or comparing when something might be true or not true? Are they thinking about their thinking to recognize what just happened? But how are we getting them to think and to talk? If you would turn in your notebook to page 36 and 37. And take just a moment to read through the description on page 36 of what discourse is and what discourse isn't. That's the two lists at the top. And then look over to page 37 and read the descriptions of the three types of discourse: procedures, facts, justification, and generalization. Once you get there, what connections are you seeing between the descriptions of the student discourse that are on page 37 and the three overarching habits of mind: make sense, justify, and generalize? So think about that with your partner. And then also go back to what is discourse and what isn't. Is there anything on that list that surprised you and that you're curious about? So if you would stand up, go find a partner not at your table group. You can just stand with them, chat for a couple minutes. What connections are you seeing? And did anything surprise you on the list of what is discourse and what isn't?
All right.
How are you?
Everyone move. Ooh,
Yeah,
yeah.
a little table. 4 quarters.
Input, output.
4 after that. Each quarter. Was it a plus or not?
Ooh.
I feel like
Doug's saying, yeah, those three habits were a lot more than negative, and your team doesn't post a lot of positives.
reading through this, I feel like I definitely have been doing a good job.
Oh, yeah, if I've done it, do it the second one.
That's awesome.
Sending them.
Wait a minute.
Who does that? Who's like the second one?
Oh, okay. So, no matter how I answer that.
Yeah. What?
All right, if I can pull this together. Would like for us to kind of dig into some of the things that you were talking about in your partners, wondering if you need a quick break. Are you guys okay, or?
I can use a break.
Okay, can we
No break, I'm also gonna take a break.
talk about this and take a quick break? Okay, there we go. We're gonna talk about this, and I'll give you a quick break, because the next thing we're gonna do is take a look at a video. Okay? So, a couple of things that I eavesdropped on as I was moving around and kind of heard questions being asked about. So if you look at page 37, the one that looks like this, okay? A couple of pieces to call out given the questions that were being asked. So first, under the procedures and fact area, there's kind of two separate sections. The top 3 bullets are underneath a heading that says no evidence of reasoning, and then the bottom 3 bullets are under a heading that says uses meaning, definitions, properties, known math ideas to describe reasoning. Okay? So I think it's important to call out that we can get a variety of types of procedures and facts in the classroom. It could be that the student is saying the answer is 3. Okay? There's a fact. Or it could be a correct fact, it could be an incorrect fact, but they're just saying the answer is 3. Versus the answer is 3, and here's the steps that I went through to solve it. So an explanation that comes along with it. So there's some reasoning included. So the other piece was that I heard was a question about are procedures and facts something we should stay away from? No, I don't want to imply that procedures and facts are bad. We just don't want to live there. So how can kids use those procedures and facts that they're making sense of to be able to justify and generalize about the mathematics? So as we're listening to student discourse, we want to hear all 3 types of discourse coming out, not only one kind. Does that help a little? Okay. So now what questions do you have? Those were 2 that I heard in a couple of places I wanted to address. What questions might you have? Or observations did you make?
I've got a question.
Absolutely.
So, I mean, I think about when I learned math and how, how it went for probably most people in the room. And there was a lot of procedures and facts stuff back then. I still learned math, so I mean, that's probably not horrible, but I'm just thinking if you are a teacher and you're picturing your lesson, and I know you can't apply a hard and fast number to this, but when you're thinking of breaking your class period maybe into percentages, should they be spending more time on one particular type of discourse than another, you know, on average? Or, because if you have 75% procedures and facts and then the remaining 25% is the other two, you know, is that a good lesson? And I mean, I suppose it depends on the concept, but.
So how would you guys respond to that?
I think sometimes within a unit, as you're starting a unit, just introducing the concept, you're probably leaning a little bit more towards procedure and facts. But by the time you're at the end of the unit, you're probably more of that justifying and generalizing. So it might even be a transition throughout the unit as far as what kind of answers you're looking for, as far as what percentage of type of discourse types.
Other thoughts?
Well, we're encouraged to open a lesson with something that's, you know, a juicy type of problem that kids can sink their teeth into. So, you know, the idea of the way many traditional math textbooks are laid out. Here's how you do it, okay, here's some word problems, do it. Here's an application, you know, here's a larger problem. It seems like that might be turned on its head, and you turn it around, and if kids discover the algorithm good, if they don't, you let it go, and then later on you say, well, here's what another, parenthesis, smart kid showed me in an earlier class. What do you think about this?
So I think what you're calling at is looking for those places in your lesson where there's going to be opportunities to justify or generalize. And a lot of times those are the questions that are later in the format of the lesson. Can't say they're across all curriculum, but that's not uncommon. So it could be that you launch with that, and then the kids are making sense of that, thinking about how they're going to solve that. And it could be that if you're thinking about access for all students, that at some point in the lesson you say, well, here's a couple of ideas. How might this spark your thinking? How do these make sense? What of these always work? I mean, you could ask some of those questions. We would be careful with, you know, thinking about whose work you're bringing forward so that you're getting a lot of voices out there. We want to be careful about the smart part, because that implies that means that there's some kids that aren't.
Yeah, you would never say that, and you would never discourage anyone from presenting their work,
Right.
or even saying, well, that's wrong. You say, you justify how, okay,
Yeah.
thank you, and
Yep, absolutely. And what I hear you calling out are places here where the kids might be able to justify. They might be thinking about a representation they could use to make sense of that. I mean, there's lots of places for kids to have access. I don't know that there's a hard and fast rule about the percentage of discourse. I mean, not one that I've ever heard of nor really tried to quantify.
I wouldn't want to quantify it. I just think, you know, if you're looking in general, there's 3 types here.
Mhm.
You know, I guess what would you look for?
So in my own classroom, and when I have the privilege of being in other people's classrooms, I really look for that continuum. So and we're going to do this in a video in just a minute. I'm going to ask you to, you know, write down some of the things that a student in the video is saying, and then we're going to think about what kind of discourse did we hear. And my hope is that we'll hear in the video, or that you'll identify in the video, the same things that we would look for in a classroom, which is a little bit of all of it. Then we might need those procedures facts and to be able to make sense of them in order to be able to justify. Or we might jump to a generalization and think, gosh, I wonder if this is always true. And then we back up to a justification to figure out whether that's always true, and that justification might include some procedures fact. So trying to think about how that could be really fluid in the classroom. And hopefully you'll be able to see that same thing in the video in just a moment. Yeah.
Well, just follow up to that, then do you recommend or suggest a percentage of discourse in each class period?
I don't have a number in mind. I think the kids should be able to talk and make sense of the mathematics in a way that's appropriate for the math that they're working on. And if that means a longer period of time because they're working as a group on a big problem, versus maybe you have multiple opportunities for them to check in with a partner periodically throughout a lesson because you're kind of making sense of things along the way. I don't think there's one answer to that. I think there's lots of great ways to encourage discourse. And I think as you wander through classrooms, like even each other's classrooms, that you're going to see that continuum Some people are in projects, some are in lots of opportunities, some are in fewer opportunities but for longer periods of time. And then it all goes back to what's your core math idea? What is it you want kids to understand today? And what are you intentionally doing to support kids in getting there? And again, I know that's probably not the answer, but that's the answer I have for you.
So I guess the reason that I'm asking, I don't just, this isn't just a problem for math. You know,
Yeah.
I mean, like I'll hear from history, well, they need all this vocabulary before they can start
Yeah.
doing anything with it. You know, and I mean, I don't believe that. So I guess I'm more thinking through the lens of the teachers, like what would be, and maybe we're working toward that, but a vision of, you know, how do you find those places and intentionally plan for them? And when you look at your whole year, maybe,
Yep.
you know, what would be a good balanced approach? Are there any ways for you to kind of calibrate your own work?
And I think that calibration piece is really important, both in having somebody maybe come in and gather that data for you so you can reflect on it, as well as being able to get into other people's classrooms and think about how they're making that happen. And again, we're not too far into this, and we haven't talked a lot about discourse, but one thing you might consider doing, and we can talk about this tomorrow a little bit before January, is would there be a way for each person to get into somebody else's room and capture discourse for that teacher? Not because they're there to make a determination or evaluation about what's happening, but just to capture that discourse and then hand it to that teacher. So in this 15 minutes that I was here, here's what I heard your kids say. And then as the teacher, I get to reflect on what kinds of discourse was taking place, where did I elicit discourse that was really meaningful for the lesson, and where else could I have done that? It's not right or wrong, good or bad. It's not about judging, but thinking really hard. How do we help each other as we go down this path? Yeah.
The interesting part of the conversation for me historically is we're in our third, since I've been here, we're in our third math curriculum. So we started, when I came, we started with Saxon, which is,
Could you get in front of the camera as you're talking?
no. So we're at Saxon, which was very procedurally
Yeah.
based and,
Yeah.
and spiral approach, and kids just keep
Yeah.
coming around to it. Then when we did our TDG training, we just switched over to CMP math. And so we were kind of in these math wars at the time, which is the better curriculum. And if it was said once, it was said a half a dozen times during that TDG training. It's not about the curriculum. It's about how you teach the curriculum.
Yeah.
So Matt's response piqued a question in my mind, which is when you're trying to build math for conceptual understanding, do you lead with procedure to build conceptual understanding, or do you lead with conceptual and then identify the procedures within it?
Depends on their background.
Yes.
I was going to say, yeah, exactly.
Yes.
That's my, yes.
And
Right.
The answer is yes.
Yeah.
So my press would be is what is your intentionality? What are you doing with the kids to help deepen their understanding about the mathematics, and why are you doing it that way? I don't know that there's a right answer, so I'm going to go with Matt that yes, but what are you doing? Why are you doing it? How is it supporting students? And then if your students are going down the path they need to, fantastic. If they're not, or not all of them, what might you tweak? What might you try different? And that's that formative piece.
Yeah.
So I think if we were to survey everybody that's ever been involved in the work with that exact question, we probably would get lots and lots of thinking. Might go back to what the content is, might go back to what the student's experience is, it might go back to how your plan is for helping the kids make sense of something. Again, I'm circling back around to Jason's idea that maybe we talk a little bit about this and then take a quick stretch break. So is it okay for it to be pretty short? Like 5 minutes, is that long enough to run to the restroom or get up and stretch? Then we're going to see a quick video, and then we're going to wrap up for the day, and the goal is to be done at 2:30, so that if you've got activities after school, you can get to those. So let's take a peek at a video where a teacher is working with her students around a conjecture. What I'm going to ask you to do during the video is to use page 37 that we were just looking at, and to jot down what the students are saying that you think might be a procedure, fact, a justification, generalization. If you're not sure, jot it down in one of the boxes, and you can always draw an arrow to another box after you have a conversation with your partners. I do want to say just a real quick word about video. and this probably is unnecessary, but I feel like I need to say it each time we go to watch a video, is that anytime we get a glimpse into somebody else's classroom, we're being offered this gift, and that we need to take it as the gift that it is, so we get a chance to think really hard about what this particular teacher's students are saying and doing, and how she's helping them make sense of the math. So it's not our opportunity to critique what she's doing, but to think really hard about what kids are doing. So just my little caveat before we have a chance to do this. Let's see, lights, can we, light switch where we might be able to, oh, perfect, that. So I've got my speakers hooked up, but if it's not quite loud enough, let me know, and I will certainly crank it up a little bit more and see if I can make sure that you can all hear it. And again, try to capture verbatim, not your inferences, but verbatim what students are saying and doing in the video. Oops. That won't work, will it?
Is that a chalkboard?
It is a chalkboard. All right. And then we do it this way.
It's kind of like 9 plus 0 that equals 10 because 98 plus 0 equals 98 because if you erase the 0, it's like nothing there and 0 doesn't stand for completely, not anything.
What does 0 stand for? I think that we're kind of talking around that circle. We've got this thing, and what does that stand for?
Nothing.
Nothing. What do you mean nothing? I mean like,
It means you don't add anything.
no, you mean, okay, listen to what Patricia said. Patricia said that if you're adding 0, it's like you don't add anything to the group. What would that be? That's an open up. What could you put in that for that number sentence to make it true? Joseph?
841.
How come?
Because it's for the blue. Can I go get some juice?
Okay. Joseph is going to get us some juice. Please do not get 841. Good.
Oh.
Yeah.
And you want to add something else? And the only numbers you know are 10 and 0.
Okay.
And you want to add 0 onto 10. Then you add it on. It's still 10.
So you mean, you gave me 10 blocks right here, 10 cubed. Now if you're going to give me 0 more, give me 0 more. Do you agree with, does that make sense?
Yeah.
Alan, what were you going to say?
Like if you add 0, it's just going to be the same number.
If you add 0 to a number, Ellen says it's just going to be the same number. Is that always going to be true?
Yeah.
It sounds to me like we've got an idea of something that's always going to happen in math, right?
Mm-hmm.
That it's always going to be, I think you guys are agreeing with Ellen that if you add a number, add 0 to any number, it's going to stay the same. And we have a word for that we sometimes use, and that word is conjecture. Because conjecture means that this is something that we think, near as we can figure, is always going to be true. Ellen, can you remember what you told us? What did you say?
If you add 0 to a number, the number will stay the same.
If you add 0 to a number, the number can we think of an example of a problem, a number sentence that might illustrate that?
Please.
Taylor?
9
Mm-hmm.
plus 0 goes 1.
Is that something that kind of illustrates what we're talking about? Is 9 plus 0 equals 9? Joseph, what were you gonna say?
I was going to say 9 equals 0 plus 9.
Should we do it the other way too, just to show? Remember how Joseph started out reminding us that it didn't make any difference whether we start out with a single number and then put an operation later?
If any number minus 0.
Oh, maybe I was going on to something else. Hold that thought while I tape this up.
So we give you a minute to finish writing down anything that you've heard that you want to make sure you talk to your partner about. So I'm going to ask you to check in with your partner and review what you were writing down. Did they place those same statements in the same spot? When you thought it was a conjecture, did they think it was something else? If they wrote something down in procedures and facts and you thought it was a generalization, you'll be looking for those places where maybe you had differences and where you put an example. And then come together in consensus with your partner where you could share an example of a procedure fact, a justification, and a generalization. What the student said and why you think it was that kind of discourse. I will give you a chance to talk with your partner.
Separate from each other. Came on when I.
Generalizing with that last one.
Okay, so generalize with
I did that.
examples, Oh, yeah. Because you're not reasoning.
Right.
Oh, I see.
You captured what he said, yeah.
And then justify it with the boy.
Is that generalized? Is that saying?
Put nothing with it, so that, so put that as justified.
Illustrate that.
Public stuff in there.
And then, I guess it's good.
So how long have you
So
been
an example.
$4 years.
She asks questions that always. Try to get them
He showed that adding nothing, and there was, I like numbers. And the chapter.
Let's get a few of those examples out here, because I think in eavesdropping on conversation, there's a few that are going to overlap. So let's start with a procedure fact. Let's come over here to
We kind of all
Nancy.
agreed that when the girl was presenting about 0, it was kind of more, defining what it is, what it's, how operations work with it for adding and what they were taught. So she was basically, re-justifying what 0 was.
So she said, if you have, so does anybody have exactly what she said?
Kind of like 10 plus 0, so
Yeah.
98 plus 0 equals 98.
10, 9,
And then if you add 0, it's always going to be the same.
0 doesn't stand for anything?
Yeah.
Okay. So, yep. So you guys are calling that as a procedure fact. What are the other tables say?
Any choral answer, yes, like when they all said yes to a direct response.
Okay. Yep.
For that, I had a generalization. If
Yeah.
you erase the 0, it's like nothing is there. I had
Okay.
that as a generalization.
I put that in justifying.
So let's think. So Dan said why he thought it was a procedure fact. Why do you think it's a justification?
Because she's explaining why she's justified for everything.
Okay.
Explaining
And why did you think it was a generalization, Matt?
Because it can apply anytime.
So I'm going to take us back to the descriptions that are up here. And so we've heard 3 different people say they thought the same statement was 3 different types of discourse. Come back up to the descriptions up here. Which bullet would you use under whatever you just said you thought it was? Would you use to convince somebody else that it's that kind of discourse? I'll give you a second to look at those descriptions.
Restate what we're talking about. What's the
So-
quote from the girl?
Yeah, do you know what it is?
So I believe she said, and I don't have it written down right in front of me, but she said something like, it's like 10 plus 0 is 10, that if I take away the 0, I have the same number, or I
And the
have.
teacher said, what do we know about 0,
Okay.
right?
Yeah,
And
zero
that's
is a
what,
number,
that's where
double
she
six.
explained it.
So using those descriptions at the top, how would you justify that it's the type of discourse you think it is?
Explaining ideas.
I'm gonna start back over here. So Dan, why do you think it might be a procedure fact?
I just thought, we looked under, or talked about being explaining ideas and methods, or questioning for clarity. She's bringing up the idea of what does 0 represent, or what is it, what happens when you add 0 that's
Okay.
taking place.
Okay,
And so, to me, that was where she was starting her lesson, which was bringing clarity to it.
okay. And Renee, which were the bullets might you use to support this justification?
I think it's all of them. Give mathematical defense for an idea that was shown.
So if a student was saying that that wasn't always true, that might be her rationale back. Okay. And Matt, which bullet might you use to say that it's a generalization?
That she was making a conjecture about what might happen in her general.
So, again, I'm gonna just say right here, I don't know that there's a right answer to that. I mean, just like you all, I have some thinking about that, but I don't think there's necessarily a right answer. The conversation and bringing that out and thinking about what does it mean to have a student justify, why might we think it's a justification, what would it need to include for it to be a generalization is really important. Because when we start to think about the discourse that's happening in our classroom, we want to be able to go back to our own room and listen to our kids talk and have a sense of what kind of discourse we're hearing. So, I mean, I would not encourage a team to kind of fight to the death about which one it is. I think the conversation that we're having is what's really important. Let's get another example out there, another piece of discourse, and let's think about what it is. And maybe that'll help us cement some ideas around that first chunk.
Kid grabbing the cube and explaining it.
Okay, so what do you think that is?
Justifying.
Okay, I see his head's nodding. So anybody think that when he grabbed the cubes and put 10 in the teacher's hand and then gave her 0 more, was he justifying there?
He showed why the idea was true.
Okay, great. So that first bullet showed why an idea was true. Nice. Did you hear any general, so we have one statement on the table that we're not sure what it is. Anything else that you thought was a generalization that we might be able to think about? Yeah, Matt, you have another one?
The one he said, if you add 0 to a number, it's just gonna stay the same number.
Okay. If you add 0 to a number, it's just gonna stay the same number. What do you guys think? Generalization, and what descriptor might convince us of that?
A conjecture.
Okay, you might be making a conjecture. And depending on what they did with it, connecting it back to the young man who went and got the cubes, it might be that he was actually starting to, or at the beginning stages of a justifying, that second bullet, justifying a conjecture.
The last statement.
Yeah.
Where I wrote down anything, I don't know if that's exactly what he said, but he said anything minus 0.
Anything minus 0 is itself, yeah. What do you guys think of that statement? Generalization, yeah, absolutely. So I think about what the teacher, so do you ever have students who say something really interesting in class like that? I mean, that's a pretty great statement. So how do you decide what to do? I mean, I think we saw what she did. She said, let's hang on to that idea. You know, and
I mean, you could have them, you could try and come up with some ways to justify it.
yep. Yeah, if it went towards your core math idea for the day, what you wanted kids to make sense of, you could say, oh, fantastic, let's think about that as well. If it goes towards something that's coming up soon, you might write it down on a piece of paper or on the board or somewhere and kind of track it. Because it's when kids say things like that, we don't want to lose that idea, but we might then opt to wait and put it in place where it belongs. Questions that you might have as you're thinking about listening to the discourse and characterizing some of what you heard. What questions is that bringing up for you?
I guess, when do you say, okay, we have a general rule here? You know, I mean, how much feedback do you need to hear from the students before you, hey, let's write it down, post it up, this is what we know?
That's a great question. So how do you figure out how much is enough to convince us that we have a general rule? What are your thoughts? What do you do in your classrooms?
Formatively assess the kids so that you can see, make sure everyone has it.
Okay. You could do some kind of quick formative assessment to see who's making sense of that.
Give them a novel situation where they have to apply it. So it's not just restating the same thing you just talked about, but something new that they have to apply it to.
Alright, so this is another example. So we've got this conjecture out there. So let's try it on another situation, see how it works.
Or not even immediately, but like the next day or something where it's not fresh, and then they have to make a connection to it or something.
And it could be that you're capturing it as a conjecture, even if we haven't convinced ourselves that it's a generalization. So if we hear some things being said, you might capture a couple of them and then ask the kids, so which of these are always going to be true? And then do something like what Rebecca just suggested in terms of either, I mean, if that's like at the end of the class period, then maybe the next class, you give them something to work on where you circle back around and ask them, did these hold true? You might want to think about the intentionality of what you gave them in terms of whether you want them to recognize that these hold true or whether you're looking for that example of when they won't hold true. Absolutely. But I think what you're calling out are some of the subtleties in the instructional decisions that we make in the moment. So whether it's 2 kids saying it or 10 kids that have got on board or all of them, you're trying to decide what's that next move. And it could be capturing it and having us all think about it. It could be going on to another problem. It could be then having them make sense of what was just said. So if I have a student who just made the claim, when I add 0 to any number, I get that same number. But I've heard one student say it. I might have them then turn and talk to their partner. What do you understand about what was just said? What questions do you have? And then I can listen to those conversations and get that quick formative piece. Because I don't know that there's a right answer to that. I think that's that dance we do every day for students. So, yeah. Other thoughts?
I know something that's hard that she did a good job of, that I struggle with a lot, is that the second bullet under it's not considered student discourse, is the teacher provides further explanation or response to a student's question or comment. It's so hard to like bite your tongue sometimes. Like you want to like try to catch yourself, and you just sometimes rambling off.
And I think that's a great call out. I mean, and again, so that doesn't imply that you never want to say something in your classroom, but just being really intentional about the fact that that's not student discourse. But if we say something to the kids, then how are we going to help them make sense of it? So if it was, you were going to add something in or put a little constraint around it, how do you then have the kids make sense of that? But if we can get a student to say it, that's really powerful. Really powerful. Okay. So I want to give you a chance to jot on your important moments one more time before we start to close up. So if there's anything you're thinking about from today, whether it's a discourse from the last little bit here or earlier, take this chance to jot it down before you leave here and get to be thinking about everything else you have going on this afternoon. Give you a minute or 2 here to write in your important moments. So let's think about this evening and then tomorrow when we're back together. So first thing I'm going to ask you to do is to leave your important moments with me. And I'm just going to take a quick read through them tonight. I will bring them right back to you tomorrow and return them to you because they are yours to keep. It's just really helpful for me to think about whatever it is that you're thinking about right now. Same thing if you would leave your name tents, that would be great. I'm going to mix them up tonight so you have different partners to sit with tomorrow rather than the people you're with today, just so you have a chance to talk to the people around the room. If there's anything that you want me to be thinking about in terms of something that you want me to be aware of or that I need to know, feel free to either write a note on the inside of your name tent or just put a sticky on the front of your important moments if there's something that you need me to be aware of. Okay? Before you take off, I will ask you to tidy up your table.
I interrupt on that, Laura. We have a school board meeting here tonight, so make sure you take everything. We're gonna have to pull all the tables out and set up chairs and all that and just kind of reconfigure in the morning again. So unfortunately, we can't tonight, we can't bring things here.
Absolutely. So I'll take your name tents and your important moments, and if you would tidy up the bags, I'll pick those up before I leave today. So I want to talk about the 3 things that I'm hoping that you'll do for me this evening. The first one, Kyle, can I grab your orange piece of paper? In the front of your notebook, there should be a bright, almost obnoxiously bright piece of orange paper. If you would go to the website or web link that's in the top part where it says register for this service, and go to that link. If you've been involved in anything that Teachers Development Group has done in the past and you have your username and password, you're welcome to use that same username and password. If you haven't been involved or it's been a while, you've changed districts, you've changed schools, whatever, feel free to register as if this was the first time through. So what this will do is it'll do 2 things. One is it'll register you through this service, the Teachers Development Group. But second, and this is going to be important for us since we're going to have 2 days now and then not 2 days until January, is it'll create an online math collaborative or like a discussion board where we can, any of us can post something to it and it'll go out to the rest of the group. So if you have something you want to share or a question you want to ask, you can do that. It's also a place where I can post something and you would immediately have that information. Okay? So if you would please do that tonight, that would be very helpful. If you run into trouble, let me know in the morning and I'd be glad to help you out. It just takes a couple of minutes if there's some issue this evening. And then on consumable page 33. So again, that's the 3rd section in your notebook. I ask you to do a little bit this evening. So part 1 is thinking about a mathography. So a mathography is a quick story of how you are or how you landed where you are mathematically. So what's your experience with mathematics? It could be K-12, it could be as a teacher of mathematics, but what is your background in mathematics? Not necessarily I took these classes in college, but kind of what's your experience been as a learner of mathematics and then as a teacher of mathematics? It does not have to be long. It can be short and to the point. It can be a couple of paragraphs. It can be a few sentences. If you don't want to have to write it and or print it, put these right up here so I don't lose it. I'm going to put my email address up here. If you would rather just type it up in an email or type it up in Word and send it to me, you are more than welcome to do that as well. And I would be happy to print it for the pieces that we're going to do with it later on. So. So if you don't want to handwrite it and you don't want to have to find some place to print it or that's a pain, you just want to email it, go for it. Okay? Part 2 is a math prompt that I just want you to think about because it shows up in the article that I'm going to ask you to read. So part 2 is pretty quick, or you can think about it as you're reading the article. The 3rd part there talks about reading the article Discourse that Promotes Conceptual Understanding. And in the reading section of your notebook, that's that middle section, the 2nd section, it's the 1st article in that area. So it should be right after your first piece of purple paper. And it's called Discourse that Promotes Conceptual Understanding. And you can cross off number 4. So 1 is the mathography, a quick summary of how you got here. 2 is just a problem that shows up in the article. And then 3 is to read the article. And then the last piece down here is if you have access to your curriculum materials, to bring a lesson that you're gonna be teaching in the near future. Could be Wednesday, could be Thursday, you know, depending on what you've got going on this week. It can be a hard copy if you have access to your teacher edition, it can be electronic. So if your teacher edition is in your classroom and your sub is using it, and you've got access to it electronically, that'll work fine. Just need you to have access to a lesson for a chunk of time.
Just a lesson plan?
It could be, do your teacher guide, where you can actually look at a lesson that's coming up that you're gonna be teaching and then think about how you might implement it. But it could be hard copy or electronic. Questions for me?
Do we know in January, when we're meeting?
I believe it is Monday the 12th and Tuesday the 13th, but, and I see a couple heads nodding, but somebody double check me, okay. Yeah, it should be the 12th and 13th, and I believe it's a Monday or Tuesday. All right. Other questions for me? We've got a few minutes left here, so if you wanted to register and you have a computer here, feel free to take care of that and be done with it. It literally will take you about 3 minutes if you want to do that. And otherwise, I know that some of you have after-school activities that you have to be at. So I want to say thank you for your participation today, your conversations, the way that you're willing to engage with each other. That really says a lot about the team that's here. And so I really appreciate that. I'm looking forward to tomorrow. If there's anything you need, don't hesitate to stop and let me know. Email me. I'm good about checking email and getting back with you.
Thank you.
Yeah, thank you.
CSB.
CSB.